Okay, I think we have a good amount of people. So welcome everyone to the third presentation of this virtual ASHRAE Spring Conference. Today's presentation is going to be the engineering's role in navigating a pandemic. And our presenter today is Lucas Turnbull. He is with Thermosystems, and he's been with the company for six years. He's a sales engineer, and he'll be walking us through the presentation today. We're going to have about 10 to 15 minutes at the end for questions. You can either use the chat function or the Q&A to submit questions, and we'll walk through them at the end and provide responses. With that, Lucas, go ahead.
Hello, everyone. I hope I unmuted myself. It was a little tricky. Welcome to the webinar. Thank you for attending. My name is Lucas Turnbull. I'll be your presenter today. My background is I have a BS in mechanical engineering from Bradley University. After that, I started with Thermosystems LLC. I've been with them since graduating. I've worn many different hats and performed different roles. Currently, I'm on the Building System Solutions Division team, where we mainly do design, build, or retrofit type projects. So we are typically on an owner facing role, or even with the service contracting role as well. So we've had a lot of exposure to how we navigate the last year due to being, kind of a retrofit based team. So today I'm going to go over engineering's role in navigating a pandemic, and what that really means is we have seen the devastation a pandemic can do to our society, and we do know there are ways that we can change it for the better. We can affect our indoor air quality, we can affect the viral load that's in our HVAC systems, and we'll dive into that. To start off with, I think there was a poll at some point in time. I don't know. I just launched it. So that is pretty much going to ask you who you are, what you do. And if we can have 1 minute to answer that question, it can kind of help me steer the presentation to who's listening. All right, we got a good chunk in. It's not all the way, but it looks like we have majority of consulting engineers and other on the call, followed by owner's rep and manufacturer's rep. Pretty good spread of experience. 20 plus is being shown, as well as 6 to 10 years. They're about even at 30%. Only 15% are active in YA, but given that over 35 years and older isn't really eligible, that's not an awful percentage. And also, have you ever looked into indoor air quality? 88% of you have, while 12 have not. To the 12 have not, this will be a pretty in-depth presentation. I'll be talking about a lot of things that, took a year to build my knowledge base on. So it's going to be drinking from a fire hose, but hold on. And at the end, you can ask any questions. For everybody that has, make sure you guys at least think of one question to ask for at the end on something that you want to know. There's a lot of information on this. Instead of going over one process or one equipment, I'm going over 5 or more today. So I won't have the time to dive into the nuts and bolts. But if you want me to, either we can try to get it done in the Q&A section, or we can reconvene after this. Okay, I'm going to end the polling, and I'm going to go ahead and share the results. I hope you guys can see it. And now I'm going to stop sharing, and we will move on. So let's make sure I have control. Yep. So first off, what are we going to talk today? The number one thing I want you guys to take away from this is when we're designing a building, or when we're in a retrofit type of scenario, we are only one cog in the building mechanism. We are the ventilation and air cleaning. That's where HVAC lies. You still need to operate proper hygiene and sterile barriers to make a antiviral system work. So if you increase one of the cogs speed, it'll be slowed down by the other two you didn't touch. So make sure you address all of these. And typically my experience has shown address all of these at the beginning of the talks. Don't wait for later to realize there was forks in the road and you have to go back and ask the questions. So today we're going to talk about the background of our knowledge, and that's pretty much the information that was really generated at the beginning of this pandemic. Really the background of what you need to know to be efficient and effective. Then we'll go into technologies. That's the 5 or more technologies that I tend to utilize. And then we'll talk about methodology. And this is a personal methodology to me. And I just wanted to add it in there so that you get an understanding of my thought process when I go on a job. And I'll follow up that with some examples so that we can get your brain churning over the problem. To start off with background knowledge, ASHRAE is an awesome source for background knowledge. They're by far the most plentiful source that I've found. And if you go to their website, ashrae.org, and you follow their COVID-19 links, it'll take you to this interactive graphic user interface that you see below or behind it. This user interface will lead you down the road to building guidelines that they have released for the pandemic. It'll give you position documents, ASHRAE statements on the pandemic. It talks about just about every field you could be in. So this is a huge tool. Definitely use it. Go back and look at it. Also, to start off on the background documents, the position documents are a great place to start. ASHRAE has 3 position documents that are pertinent to what we're doing today. And they are airborne infectious aerosols, airborne infectious diseases, and filtration and air cleaning. So what is a position document? A position document is pretty much a quick reaction force. That's the way I think of it on ASHRAE's hand. And as you can see on this airborne infectious diseases, which was quickly reaffirmed to have statements and be pointed directly at SARS-CoV-2 outbreak back in February. And if you remember back in February, this was still on mainland China. It really hadn't become an actual pandemic yet. I think the WHO finally called it a pandemic in March, sorry. But anyways, so there will be a technology council that's responsible for these position documents, and they will submit it and it will be approved by the board of directors. So it's a very good system. It's very reactive, very efficient, and it contains a lot of good data. The crazy thing about this position document is that ASHRAE actually came out and made 2 statements in it. The statement number 1 in February, mind you, was that they saw sufficient evidence that SARS coronavirus 2 was transmitted through the air. The statement number 2 was, in lieu of statement number 1, we should start operating and designing our HVAC systems as such. So realize that the HVAC system will have a huge role to play in this pandemic, and we need to address it. Another background document that's good to read is a CDC study based on South Korean government contact tracing information. This was a high-rise building in urban Seoul, South Korea. I think it was 19 stories. Anyways, a company that was a call center was on the 11th floor. Someone came in, was infected. They later test positive and started showing symptoms. I think it was on the 25th of February. So the government really did hardcore contact tracing at the beginning, trying to stop this from becoming a pandemic. And they found that 43% of the coworkers that went to work with him or them became infected. And the infected people are represented by blue desks. And this is a call center, so they're sedimentary most of the day. So, and as you see, there is a cluster, and it doesn't seem to permeate entirely through the entire floor, but it's actually kind of centered to a certain area. CDC concluded that that was showing that being in an enclosed space and sharing the same air was increasing your exposure chances of getting infected. And what are those 2 studies really talking about? They're talking about airborne dissemination of viruses. So the reason why we talk about airborne dissemination is because for the most part, when we talk, sing, laugh, or cry, we are emitting droplets. The droplets are, on average, tests have shown, emitted between 50 micrometers and 100 micrometers. The 100 micrometer droplet will fall to the earth within 6 seconds due to gravity. That is actually where we get the 6-foot rule due to the velocity it's leaving our mouth at. And it's the social distancing standard is actually back from a healthcare droplet protection protocol. So the big difference between droplet protection and airborne protection is look at the healthcare. Droplet protection means they wear gowns, they wear masks, they wear gloves, and they take all that off as soon as they leave the room. Airborne protection means they're in a hazmat suit with a positive pressure, HEPA filtered breathing apparatus attached to them. So it's much different worlds, and we're at a much different severity. Now, the reason why it seems that these droplets that are emitted from our bodies become airborne is because they're mostly made of water vapor. So it's like microbiological material suspended in a water vapor droplet. And due to the way we change the dry bulb of our airborne or indoor temperatures, we actually affect our wet bulb without even addressing it. And due to that effect, we lower our relative humidity in space. And what does that do? That increases the desiccation or evaporation of the water content of these droplets. Studies have shown that there's, it's kind of a bell curve. And the bell curve kind of tips out at about 7 micrometers. And that is the average North American droplet concentration indoors. So as you see, while it might top out at 7 micrometers, and those might fall to the floor in an hour or two, there's 15% on that bell curve that are 1 micrometer or less. And those are in the air for 12 hours or even longer. And realize SARS-CoV-2, if it was desiccated to its a particle that is standing by itself, is 0.15 micrometers. So it's much smaller than this, 125, sorry. So it's something we should address and something we should understand when we're designing. How do we change that? How do we get those droplets out of the air? Well, we increase our effective outdoor air changes per hour. On the left-hand side is a chart of typical design recommended air changes per hour for different applications. A lot of the times in the field, I see 4 to 8 air changes per hour. If you go over that, you're really in a highly healthcare center or application or highly industrial process. And if you see on the right-hand side, there's a colorful Excel chart which correlates air changes per hour to time needed to effectively remove 99% of viral load and 99.9%. The thing I want you to take away from this is that 4 air changes per hour to get 99% of a viral load emitted into your space out, it takes you over an hour. As you increase, you can drop that to 30 minutes. And if you go up to 50, it goes to 60 minutes. So our aim is to take our design 4 to 8 and change it to 50 if we can. Now, that's not always possible, but there are ways to do it. ASHRAE actually has a really good Excel tool on their website. If you need help finding it, reach out to me. But it is an equivalent outdoor air calculator used for design. So it's built by ASHRAE. You can download the Excel and keep it and use it for your designs. Our first tool to increasing outdoor air change per hour is obviously ventilation. Increase the amount of outdoor air we're putting in our supply air. Now, the problem with that is we have to condition that outdoor air, correct? So first off, I want to note demand controlled ventilation that is addressed in all the building readiness guides. We should stop using that until the pandemic is in the rearview mirror. And for those that are new and don't know what that means, we are controlling CO2. We're controlling the outdoor air damper position off of CO2 concentration in space. So as the room loses people breathing out CO2, we sense that and we can back off the outdoor air damper so that we have to condition less outdoor air, i.e. saving energy. Right now, that's not our concern, and we should continue to dilute the rooms as much as possible. But while diluting rooms, realize that typical designs are looking for 20 to 30% OA. And at that 20 to 30%, this is an ASHRAE RAND study. The coil is 45-ish tons at 20%. If we ramp that up to a makeup air unit, we're going to need a coil that can perform 90 tons of cooling, which is not what we have. So we're going to lose our indoor temperature and relative humidity set points. Also in the winter, and I've seen this so much in Chicago, I literally just had a conversation about it the other week. They ramped the OA out open and it was a hot water heating coil and they burst the coil. And I've seen that over and over and over again. So realize what system you have when you're looking into ventilation. While this is a great solution, it is seasonal and it must be, you must design it. Don't just open and forget it. Ventilation, ASHRAE has stated MERV 13 or higher. I agree with that statement. And some of the data here is that this is an ASHRAE study where they did residential filters. The residential filters, I'm guessing, are 1 inch, so it would change for deeper filters. But this is the effectivity or the percent viral load they're filtering out. At MERV 5, your mean is 32%. At MERV 13, your mean is at 89%. At MERV 14, your mean is at 97%. And realize as you go up the MERV rating, your error bars decrease. So you have more confidence as you increase your filtration rate. But the problem is designed for the future. But the problem is cost, maintenance, and pressure drop. Increasing the pressure drop of a system is manageable, but it really depends on what type of equipment you have on site. If you have a light commercial rooftop or unitary type product, you're not going to have enough headroom in that fan base horsepower to increase your pressure drop by very much. So if you're doing a heavy commercial air handler built up or something like that, you can definitely increase your filters and you probably have a lot of air or headroom in that fan motor. Now, also, ASHRAE is kind of constraining how much headroom we can put on fan motor horsepower. So realize that as new equipment is shipped, there's probably a less probability that we can just increase the filtration to double the pressure drop. Also designed for the future, almost every commercial manufacturer, the ones we represent included, have a 2-inch pre-filter, 4-inch post-filter filter rack as almost a standard option. We might not show that on our selection data because it's not pertinent to what we're talking about, but it's most likely there or a selectable option. So if you can do 2-inch MERV 8 filters and 4-inch MERV 13 filters, that'd be the best of both worlds. Because one of the other things I forgot to mention, sorry, I'm moving fast, but as you go up in pressure drop and MERV rating, you also go up in cost per filter. Not only that, something people tend to leave out of their equation is you go up in maintenance intervals. So if I have a MERV 5 filter, it's much cheaper, and I only probably have to change it once a year because it doesn't get that clogged up very fast. A MERV 13, I'll probably have to go to a 3 to 6 month changing rate, and it costs much more than the MERV 5. The MERV 14 costs even more, and I'll probably be limited to a 3-month interval changing. Now, if I do a MERV 8 pre-filter and a MERV 13 post-filter, I can probably extend the life of the MERV 13 filter, that way not having to pay more every time I have to change the filter. Another big one to talk about is humidity control. So as we talked about with airborne dissemination, a lot of the virus transmission turning airborne is the fault of our own. We're conditioning our spaces, but we're not humidifying our spaces. And we're causing more desiccation than our bodies really evolved in. So with humidity control, you will reduce the distance that those droplets can travel, the amount of desiccation they have. Also, ASHRAE did a study in 1985 and produced this chart. It's called the Sterling chart, named after the person that wrote the study. And it shows the correlation between bacterial viruses, respiratory infections, ozone production, and relative humidity. And it shows how all of these harmful or cautious materials seem to not thrive in this area. So this has been known knowledge for 30 years. And we should start designing with that knowledge. The only problem being building envelope. A lot of our glass window high rises will not hold 40% in a Chicago winter. That's just the truth. We can mitigate that by sensing the outdoor temperature with our humidifiers and changing the amount of indoor relative humidity set point we can allow you. But yet it's still something that has to be addressed. So when you're designing something, if you're looking at humidity, definitely take a look at your building envelope. And we probably should be starting to talk with architects about this and how do we increase the building envelope, and how do we also keep the aesthetics suitable for them. 3 more reasons to humidify. Reason number 1, our respiratory immune system is not used to being dry. We have mucous membranes all over the internals of our body, including our sinus cavities, our esophagus, our lung tissues. And if those mucous membrane is well hydrated, it actually is our best and most effective defense against virus transmission or bacteria or any type of infection on our internal organs. And as we dry out the air, we actually dry out that layer, rendering our first and most vital protection inert. It really, really hurts us in the long run. So we should be looking into this as a society. Also, reduced quantity of airborne viruses. That dates back to the desiccation that we talked about. Also, airborne viruses seem to be less infectious. So many, many studies have been done, and they all come out with a chart that's similar to this. One of the studies was actually performed in Chicago at one of our hospitals. Pretty much what they did was they humidified one ward while not humidifying the other ward. And they saw that a relative percent infectivity of the unhumidified ward was much, much higher than it was in the humidified ward. So you can gain 4 times infectivity by not humidifying your space. Another technology we can utilize is UVGI. UVGI is a wavelength of light. So UVGI, is ultraviolet germicidal irradiation. And what that, I'm always going to say UVGI just because this is too many words. But what that is a mechanism that produces a wavelength of light in the UVC spectrum. The UVC spectrum is in the ultraviolet spectrum, which is shorter wavelengths than we can see in the visible light spectrum. It's subcategorized into 4 categories. The ones we care about is UVA, which tans us, UVB, which gets blocked by our atmosphere, but still burns us since some of it gets through, and UVC, which is completely blocked by our ozone layer. This UVC, and it might be a fault of evolution or something else, but this UVC has a high germicidal efficiency. And it actually has a bell curve of efficiency within the UV light spectrum. And it just so happens the technology that was developed in the 50s and manufacturers are mass producing, and there's multiple different chains to get these low pressure mercury vapor light bulbs, comes out within 5 nanometers of that peak germicidal efficiency. So it just so happened that in the 1950s, they did their math correct and they were able to produce something that is almost at the peak of the germicidal bell curve. Also, another big thing about UVGI, depending on the placement, you have to place these lights behind the cooling coil, pretty much bathing the cooling coil in the drain pan in radiation. What these do is they kill the microbiological growth that's on the coil. I don't know how many of you have seen coils in the field, but I've seen my share of these coils. And this is a 10-year-old coil that had good maintenance for the first 3 years, and then it kind of spurted out. Well, if we shine a UV light on this coil for 6 months, it turns into this coil. And these are actually the same coils after 6 months of UV irradiation. And what we're doing is we're actually improving our heat transfer and our air pressure drop on that coil, giving our 10 to 25% efficiency gains on an existing equipment. Now that range really depends on how old the unit was, how good the maintenance was, XYZ. But in the end, we're shining UV light in here, we're killing that growth, and we're taking the insulation off our heat transfer fins, improving that heat transfer. And we're also reducing the gap, increasing our or decreasing our fan pressure drop that we're adding to our fan load. So these are, the way I go about UVGI is I show you a system that does kill on the fly. which is antiviral. And then I discussed that if we leave a quarter of those bulbs in post-pandemic, you will see an actual benefit to the system past just killing everything in your air. And then finally, bipolar ionization. So I'm not going to get in the weeds on this because there's a lot of different techniques to do this. In the end, ionizing, all you're doing is you're creating an electric field. You're running molecules through that electric field then ionizes or charges the molecules. The one we're looking for is to ionize water vapor in the air. We will produce a hydrogen atom, or hydrogen ion actually, and a hydroxyl radical ion. That hydroxyl radical is the one we care about because that hydroxyl radical will oxidate lipid membranes of viral organisms. So that's what we care about. Watch out for ozone generation. If you don't control that electric field very well, you can overshoot. And the electric field we control to is 12 electron volts. If you overshoot, you start creating ozone. So be careful, make sure you trust your manufacturer and make sure they can prove that they don't produce ozone. So methodology, I'm going to fly through this. I'm running a little late on time. So there's two methodologies and it is a fork in the road. And this is a conversation you need to have at the very beginning of your IAQ site visit. The first fork is something I call return air treatment. And like I said, this is personal to me. This isn't really technical. But what I'm going to look at in return air treatment is, first off, I'm going to set the expectations. The expectations of treating your return air are not that we're going to disinfect the space. What we're going to do is, if there is an infected individual in your space, we're going to suck all the air out of that at a certain rate. From there, we will disinfect that air and return it to the space. Now, where this comes into a huge conversation is if you have central HVAC systems on multiple zones. Because the biggest thing we're going to do is we're not going to take that infection and transfer it to an uninfected zone. We will clean it before it gets there. So that is the expectation the owner has to have. I'm not cleaning the space. I am cleaning your air. I am keeping your ventilation clean. And the way you can do that, like I said before, you look at the OA damper, you look at the filters, humidity or UVGI goes around these coils. And I added this picture in here just so you can kind of conceptualize. Now, this is a small air handler, and this is even smaller rooftop unit. Yes, I can change the OA damper on this. How much headroom do I have in that fan to increase the filtration efficiency? Depending on the type of rooftop we're talking about, whether it's a light commercial 5-ton unit, or if it's a semi-commercial, industrial type unit, and I have a design and it's designed to a certain spec where I can actually change my fan motors. Most of those light tonnage or unitary type units are kind of cookie cutter. You get one option. It's a 3 horsepower fan. We don't care what filters you put in there. It'll just change your CFM, right? And also, I have no place to put a UV light or really a humidifier in this unit. So I can't count the amount of times I've been on a roof and I see a 3-ton unit and I say, well, we have to look elsewhere. So ways we can implement the technology: humidification. You can do it during design. You can do adiabatic, or you can do it during retrofit and do isothermal. Both can be designed, but this actually lends itself to retrofit much easier because all I need is a supply water line, a drain line, and power to my unit. And for the most part, I can humidify anywhere. Once again, building envelope. You have to take into consideration building envelope. In Chicago, we will rain water down windows if you humidify, if you try to keep it at 40% when it's 15 degrees out. UVGI, the kill on the fly application is what you should be requesting. Realize that that is a high output bulb. So there are 2 different types of UVC bulbs. One is a standard output, and that is the bulb that is used for cleaning coils. So it needs 24 hours of exposure to kill anything. The high output ones is designed to do kill on the fly airborne protection. they are designed to kill anything in a quarter-second exposure. So there's a lot of difference, and there's a lot of wish-washy stuff coming from different people on, I can use a standard output to do kill on the fly. Well, no, you can't. There's the chemical makeup inside the bulb is much, much different. Also, there is a chapter in the ASHRAE applications handbook. If all you YAY members want to go look at it, it's a great chapter on how to apply UVGI. This picture is right out of it. You can put it in front of the humidifiers. You can put it in between the heating coil and the cooling coil, or where I recommend most times after the cooling coil. There's also an option, we can put it in the return air ducts, return or supply, but typically return air ducts is what we look for. And these have a 1-year bulb life. So the maintenance interval is you have to change the bulbs every year. Ionization, typically these are mounted to coils. They're pretty easy to install. The big difference between this type of system and this type of system is amp draw. A lot of the times when I'm doing kill on the fly applications with UVGI, we realize that we don't have a 120 circuit with enough amperage anywhere near us to support that. And if you find yourself running into that problem, ionization can be the key because it's much lower power draw and it's very simple, similar installations. The second methodology is in-space air treatment. So what we're going to try to do here is reduce the chance that an infected individual in a space will infect another individual. There's multiple ways of doing this. It's not a 100% guarantee, and you have to look at it and you have to aim the owner's expectations to the, I'm going to increase your effective outdoor air change rate with this technology. It's not a cure-all. The ways we can do it, once again, humidity control. We can put humidifiers in the space, isothermal, adiabatic. All I need is water in, water out, and power in. These will fit actually in your ceiling grid if you want. Upper room UVGI. So this is really where UVGI was initially designed. It was designed to be an upper room, and it was designed back in the day. But there are a lot of research papers out there on it. I suggest going and diving into that. It's actually pretty interesting. This is one where it looked into the effective air changes per hour of a UVC upper room device. And it actually ran it during the summer and winter, which I thought was awesome because it's taking into account desiccation, right? It's taking into account lowering the mean mass diameter of the droplets that people are emitting. And in the summer, with 2 air changes per hour and 1 UVC, gives you a 95% confident interval of what that effective air change per hour is. And then they estimated what it would be, leaning towards the conservative side. So with just 1 UVC fixture and only 2 actual air changes per hour in the summer, you can get your effective air changes per hour up to 18. If you're doing it and designing it for the winter, you actually can go up to 110. So this shows the power that these units have and why they were utilized in the tuberculosis outbreaks of the 40s and 50s. Also, placement is key. This is the 8-hour dose of UV irradiation, 0.2 microwatts per centimeter squared. And what that typically is, and you have to check the manufacturer you're working with, but most manufacturers have it at the mounting height. What that means is you have to mount this higher than anybody will be in your space. So typically we say 7.5 to 8 feet is probably, we don't have any 8 feet people walking around, so that's probably safe, but minimum would be 8 feet. And this will be your kill zone. And we're using the natural convection of the room to get the infected particles up into the kill zone. In-room HEPA, great option. They roll around on wheels, they plug in. I do want to note, watch out who you're buying from. Make sure you trust your manufacturers. Is this unit actually equipped with a real HEPA filter? How deep is that filter? How long will that filter last until it's clogged up? What's your maintenance interval? Can you actually replace that filter? All of those questions must come into your head when you're looking into a HEPA system. Also, recirculation. this fan needs to be powerful enough to not recirculate in the corner and pretty much clean its own air. So if it's a reputable manufacturer, you can ask for CFD or computational fluid dynamic model of the filter, and they should have it if they know what they're doing. Also realize maintenance interval, cost versus maintenance versus coverage. How much am I actually covering? Is it actually worth it? Are there better ways to increase my UVGI? Are there cheaper ways? What is the maintenance interval on this equipment? How deep are my filters? There's a lot of variables in HEPA filtration that a lot of manufacturers are kind of just putting in a pretty box and disregarding. So make sure you keep that in mind and ask those questions. Ionization, once again, think unitary. Unit vents is an application we've been doing in schools heavily. All we need is 24-volt power. It's very low amperage. And you just sheet metal screw it to the inlet of your fan. We're getting perfect, like literally the best mixing of air as we could get in a system by mounting it like this. And ask your ionizing manufacturers if they are certified by UL 2998. What that is it's a certification of ozone production. So they put it in a box, they let it run for 12 hours, then they measure the ozone. Ozone does have a background amount because it's naturally generated. Realize anytime you ionize things over the 12 electron volt bandwidth, you create ozone. So lightning strikes or even sun's radiation hitting our magnetosphere, that's where our ozone layer comes from. So realize that's the process that's creating the ozone. So if you can't control that electric field, you'll produce ozone by accident. And this is 10 times less than the EPA background level, which is good because we're in a space and we're not gonna be cycling that ozone out as much as you would outdoors. So make sure they follow that and can prove it. I'm on to the examples now. This was a downtown high-rise building where they didn't own the central HVAC, right? They're renting the space and they had access to their VAV boxes, but it wasn't very good access. So they wanted to do in-space treatment to get a return to work plan together. And they were heavy on upper room UVGI. While I agree, it's one of the most effective ways of doing it, I disagree that it's applicable everywhere. And I had to show them with these two slides. So to cover their entire workforce with, well, not even entire, but the majority of their workforce with upper room UVGI systems, it would take 52 UVGI lights. If we went to ionization and we're able to get to their VAV boxes, we could decrease that number down to 13 ionizers. And we're looking at a equipment cost to owner difference on the 10x scale. So 6,000 versus 60,000. The final plan and the way you should really incorporate your designs are a mix of these two. So I ionize the high square footage, low movement areas, and I UVGI the high movement, low square footage areas like the reception, the kitchen, the conference room, the important meeting rooms, and get their overall costs down while increasing their overall system efficiency. Another example in a townhouse, this is a chart that everybody needs to see and realize what it's saying. At 0 degrees and 50% outdoor relative humidity, we bring that in and we heat it to 70 degrees, and our relative humidity of that 70-degree outdoor air is now 3%. Talk about desiccation. We're just asking to have a problem with that. So we went in, these guys were actually looking to ionize. We talked to them. It was a mansion on the north side. They have 6 air handlers in their house, if you want to realize the scale of their building. But we started talking to the owner of the property and got into it might be worthwhile to humidify. Another example is restaurants. This is Kamahachi in Old Town. If you get a chance, stop by. They have great Japanese cuisine and are great people. But their dining area is served by one 15-ton commercial rooftop and 3 3-ton residential furnace splits. They were looking at, they kind of reached out to us and said, how do we increase the air changes per hour and reduce the exposure chance of our customers? So we look, in the end, we ionize these air handlers and rooftop unit, and then we place upper room UVGI in strategic places where there would be congregating of individuals, like at the bar or the sushi bar. So mix and match is really the way you want to go. A university example, they had 2 air handlers that served different wings of their campus. They were looking for airstream disinfection. We looked at downstream of the coil and realized we didn't have enough 120 amperage nearby, and it would have been cost prohibitive to pull that amount of electricity. So we ended up going, this is the heating coil and this is the cooling coil. By placing the lights in between those 2 coils, I actually have the amount of lights I need, because UVGI lights are affected by the ambient air temperature and the ambient air relative humidity. Realize there's a chemical process going on and it's dependent on pressure. The pressure is dependent on the temperature of the bulb. And so the temperature of the bulb is dependent on the air temperature. If it's downstream of a coil, it's going to be 55 degrees. If it's upstream, it could be 75 or higher. So you get much more effectivity out of much less bulbs. And then the crown jewel, healthcare. They wanted to UVGI their airstream, and they did a kill on the fly UV system. And behind it, they put humidifiers. So they're trying to tackle in space as well as return air. So in conclusion, start early, state your goals, make sure your owner understands the expectations, or even yourself understands the expectations. Implement all different technologies in the one system, increase dilution, increase filtration, increase humidity, add UVGI or bipolar if you can, and always try to mesh them together to give the most efficient and effective system to the end user. Once again, remember, we're only one cog in the game. They must address the rest, and always aim to increase your effective air changes per hour. With that, any questions? Actually, sorry, not used to presenting like this. I'm going to go and read the questions in the question and answer box. Now's the time to add them if you want to get some in. First question from Joe. Is there an increase in energy costs when you switch to MERV 13 filters from MERV 8? Joe, yes, there is an increase, and that increase comes from your increased fan base horsepower. So when you increase the pressure drop across those filters, you increase the static pressure the fans have to overcome to operate. Now, depending on your system and depending on your airflow, it can be a large or a smaller increase, but yes, your energy costs will increase. To what extent, it might be minimal. It's not something I would worry about. If that's my deciding factor, I'm throwing in MERV 13s every time. As long as my system can handle it, I don't think the energy cost will be detrimental. And Jen asks, are clients' concerns with ionization involves risk in creating ozone as a byproduct, and wrote no real data on whether it works or not. Can you please comment on these concerns? Yes, I can. The first comment was creating ozone as a byproduct. And I would agree, that is a risk. And you have to know what manufacturer you're working with. There are a few manufacturers out in the commercial realm that are tested to UL 2998. And this might have been asked before I got to that slide, but there is UL certification for zero ozone production. I think so EPA's limits is something like 50 parts per billion. This tests the 5 parts per billion, which is pretty much background ozone. So there is ozone present at all times. Any electric field will create it, and we're surrounded by electric fields. Realize we're using microwaves and whatnot. But yes, there is a chance, but UL has addressed this and does have a certification, and it's called UL 2998, and I would look into that. And the no real data on whether it works or not. So there is data out there. I like to reference the best test I've seen so far. is the Spanish Ministry of Defense performed an experiment. I think it was in May. So it was right when they were like on the tail end of being slammed by COVID. And what they did was they mocked up a hotel room as a intensive care room. And they dispensed MS2, which is a stand-in for SARS coronavirus 2, because it's a virus. It's just not as infectious. It won't harm anybody if it does get out. So it's not like a level 4 controlled study, but they did dispense a virus in the room and measured its airborne content and its surface content of viable virus strains at different times. And they showed within 10 minutes that a ionizer, which was on a fan coil, think mini split fan coil, in the room, there was a substantial difference between, the placebo one where there was no ionizer on and the actual one where the ionizer was on. And it was it showed in a decay rate that was much quicker. I think the numbers they came out with were like 99 in 10 minutes in air and 95 or something like that on surface. But there has been tests. Reach out to your manufacturer's reps, and I would suggest reaching out to every one of them and see what their answer is, because that will really weed out the people that know what they're doing compared to the people that are just out there wheeling and dealing. But I do see evidence that it does work and you can find it. Another question on independent researchers on the effectiveness of bipolar equipment. So I kind of just answered that, but I'll double down since there was 2 questions on it. ASHRAE 62.1 allows you to put bipolar ionizers into your design to decrease the amount of outdoor air that you need to bring in. So that would be the statement I have. ASHRAE has already looked into this and they put that in their design guides. Other than that, there are independent studies. The problem being is like what I was attributing to before. The technology is semi-new. Well, it's not new. The technology is old, like the circuit design is old, but the materials we're using to implement are new. So the one that I'm talking about is a carbon fiber needlepoint bipolar ionizer. Now, the difference between that and the old unit that kind of set the stage for no one really looking into this is different construction. And the old unit had kind of an insulator between its two electrodes. And when it made that electric field, it had to get over that insulation. And it was hard back in the day, and they would overshoot all the time and create ozone. And they still produce units like that. They're typically made out of glass. But now with the needlepoint and the carbon fiber construction, it's much easier to control our electric field. So I would say look into that. I know that there hasn't been independent researchers, but also realize that a year ago, no one really cared about ionizers. They could be used to increase or decrease OA in the design, but that was about it. This is a new field. We're in a pandemic. You got to react fast. They are also concerned about future growth of superbugs as a result of UVC or bipolar ionization. I would say if you're worried about superbugs, stop taking antibiotics. UV or bipolar, while there is a possibility that a strain can evolve to be non-susceptible to that, I would highly doubt it. UV light in the spectrum seems to kill most organisms no matter what. So the organisms that are alive and thrive outdoors during the summer are mostly rendered inert and non-infective due to the ambient UV light from the sun. So that's probably UVB wavelength. We're using just a more potent wavelength. I've seen that. I don't know that there are any good tests on it either. And that's kind of the same thought as we're in a pandemic. They don't have time to test. We're trying to answer the question on the fly. So is there an estimate for watts per CFM for UVGI? I would say yes, there is. And I would also say I might have been using UVGI interchangeably, but there is airstream disinfection in UVGI. UVGI in my mind usually goes to upper room germicidal irradiation. And those are kind of cookie cutter. You get the watt per CFM that you get. And those are typically actually designed to kill tuberculosis, which is a much harder organism to kill than SARS coronavirus. Just has to do with the genes of the system and everything else. But yes, watts per CFM, it's not really CFM, it's watts per square foot. So you're looking at this from a face velocity view. And we're typically going in at the 500 feet per minute of a cooling coil. And with that, I would say aim for 20 watts per square foot on your cooling coil. If you're looking at a duct, those change and your watts per square foot change with the face velocity. So that's a bigger question. Reach out to me if you want more answers on that. Would you recommend combining air purification and humidifier units? My question would be, what do you mean by air purification? Do you mean ionizers? Do you mean UVGI? I would recommend humidifiers. Humidity will slow the desiccation. That will turn this pandemic from airborne back into droplet. And humidity does have an effect on UVGI and ionizers, but that effect is kind of mitigated by the pros they bring. So everything has a con. What is the technology's pro? Is it worth it? So I would say that's on a case-by-case basis, and I need to know more about what you're saying. It looks like that's units that provide ionization and humidifiers. Yes, I would still recommend that. While the humidity, so the molecule we're going after when we ionize is water vapor anyway. So increasing the amount of water vapor will increase the hydroxyl radicals we produce, which will increase the effectivity of the ionizer on viruses, right? So yes, I would say there's still some pros and cons. I'm sure the ionizers are affected by the humidity of the air, and the amount of power draw probably comes off of how much humidity is in the air. Think static electricity, but I don't think they're detrimentally effective. With that being said, I don't see any more questions.
I think there's a couple more just in the chat, Lucas.
Could you go ahead and read those?
Yeah.
I don't know how to get there.
No problem. So these are from Ryan. The first comment is, that's a huge deal. Building envelope is going to dictate what is acceptable. I believe that was referring to the building envelope conversation. And then a question about the UL 2998 credit. If that was by the manufacturer, that is why ASHRAE doesn't recognize it, since we need an ASHRAE test. And then the last comment was that ions also increase particulate size, thus increase filter efficiency.
So yeah, one of those seems to be a question. The rest are kind of statements. The question I'll answer is the UL, as in ASHRAE, whether or not it recommends it. The UL 2998 certification is a UL certification. It's not an ASHRAE certification. So I would agree. ASHRAE probably, I don't know what they have to say on that certification. I don't know why they would be against it, as it's just a reading of ozone levels. But with that being said, it is a UL certification. I mean, you need UL certification on almost any equipment that's shipped in the field. And I'm not sure if ASHRAE comments on those either. So we might be dealing with, these are two different organizations doing separate things. ASHRAE should look into that and comment on whether or not it's valid. But in the end, that test is just testing ozone. So it's a UL test of ozone generation. And if it passes that, you can trust in the name of UL that it will, or that it will not generate ozone. And it's mostly, like I was getting into, it's off of the build of the technology, not what the technology is. It's out of the materials we're using. On the two comments, building envelope, definitely watch into that. You can't retrofit humidity into everything. I've ran into that so many times this past year. I would love to. I think humidity is probably the cure to pandemics in general. Reducing that desiccation is definitely a route we should go, but we have to start at the design. That has to be iterated through the design engineers like yourselves, the architects, and even the building owner. So it's much more complex than you think, because if we don't regard that, we're going to end up growing mold in places we can't see, so we won't know, which will detriment our indoor air quality, which is the reason why we put in humidifiers. And we'll also, in Chicago, trust me, I try to humidify my apartment and I'm raining water down my windows constantly from about October to about May. So it's not easy. Yeah, and if that's it, thank you for your time. I enjoyed talking with you. If you have any questions, reach out to your thermal systems sales engineer. They can set something up one-on-one with me if you want.
Thank you so much, Lucas, and thanks everyone for joining us.